Okay, so welcome back. So now what we're going to do is we're going to look at this type of polynomial. We're going to factor out the greatest common factor, which in this case is, we're looking at common monomial again. And so notice, again, we want to find the greatest common factor, right? So what's the greatest factor of 2 and 4? That's going to be 2. The greatest common factor of the a's is a, right? We look for the largest exponent that we can factor out. And then the greatest common factor of x is going to be x squared, right? So what we're going to do is we're, again, write this as factors. So again, we're going to use the intermediate step, and we're going to write this as 2ax squared times 2 plus, now how can we write this as a factor? Well, watch. We can write this as 2ax squared times 1. And you might be thinking, okay, where does that 1 come from? Well, watch. Because I can't leave nothing behind, right? And if I use the distributive property, once I factor it, if I use the distributive property, I should go back to what I started with. Okay. Now, if you want to see why I put the 1 there, let's get rid of the 1. And let's divide everything by the common factor that we found. So let's divide this by 2ax squared. And then we're going to divide this by 2ax squared. And this by 2ax squared. Okay. Now, notice what happens over here. This cancels with this, and this cancels with this, but this equals 1. So this gives us 2 plus 1. So notice that, okay, so there's the proof in the pudding, right? Remember, factors, right? If a number divides another number, it's a factor, right? If it divides evenly another number, it's a factor. So we just found that 2ax squared is a factor of both. It's a common factor. So if I divide everything by 2ax squared, then things should drop out, the 2ax squared would drop out, and see what's left behind. Well, this cancels with this because 2ax squared divided by 2ax squared is 1, right? Any number divided by itself, except for 0, is 1. And so again, 2ax squared divided by 2ax squared gives us 1. And so that's where the 1 comes from. So again, so if we look at the expression, so now we're going to factor, right? So let's put a 1 here. So now we're going to factor out, and we get 2ax squared times what? 2 plus 1. Which equals what? 2ax squared times 3, which equals 6 ax squared. But the point of this isn't the fact that we got 6 times ax squared, but the fact that the main purpose is making sure that you saw that the 1 has to be there. That's a common mistake with students. What they will do is they'll do something like this. They'll go to factor out the 2ax squared, right? And what they'll do is they'll write this. They'll say times 2, because they'll think that when they factor it out, this becomes 0, right? They think it just goes away. Remember, you should get back to what you started. Oops. You should be able to get back to where you started, because look at this. if you look at 4ax, right, I've got 4 of these, right? I've got 4 of these, and then I've got another 2 of these, right? Let's call these apples and apples, right? So I've got 4 apples and 2 apples. Well, how many apples should I have? I should have 6. Well, if you do here, I only get 4, right? So something went wrong. Okay, so again, if you're ever in doubt, use the distributive property and you should get back to what you started. Okay? That's it. See you next time.